Welcome to session 2. My name is Elizabeth Quinn. I'm from the ANU, Department of Economics and Society, and so I'll be the chair of this session. So I hope you've enjoyed session 1 so far. We're going to shift the focus today for this part, looking at the valuation and method work for Torch. The work that you saw before provides the basis to the work that we're doing now. And this is ongoing work. So our first presenter for today is Professor Stavros Petrou, and he'll be presenting on the reduced form PedsQL. So I'd like to invite Stavros onto the stage. And yes, Stavros has come all the way here from the UK, from Oxford University. So he's still working on his notes, so I'm just going to introduce him a bit more.
Thanks very much, Elizabeth. Thank you. I'm going to focus for 10 minutes on the work that we did to develop and validate a reduced item set from the PedsQL generic core scales. So we decided to focus on the PedsQL generic core scales for the valuation study, but the PedsQL includes 23 items. We wanted to develop a reduced item set from the PedsQL generic core scales to make it more amenable and tractable to valuation. So the aim was to use rash mechanical classical psychometric methods to develop and validate a reduced item version of the PedsQL generic core scales for Australian children, which is amenable to valuation in subsequent studies. So, as Alison's already mentioned, PedsQL generic core scales are one of the most widely used measures of childhood health-related quality of life, but we believe that is probably the most widely used generic measure of childhood health-related quality of life. And the idea here is to develop a reduced item set which would be accompanied by a valuation, a value set, a performance-based algorithm that could be applied both retrospectively and prospectively to various research studies and clinical studies that collect PedsQL data to generate health utility values. So there are different versions of the PedsQL generic core scales that are delineated by different age groups. There are different age-specific modules. There's a toddler module that covers children that are aged between 2 and 4 years. There's a young child module that covers children aged between 5 to 7 years. The children's module that covers children aged between 8 and 12 years, and the teens module that covers the teenage years. There's also a young adult version of the PedsQL. We haven't focused on the young adult version of the PedsQL within Torch. There are different respondent types, so therefore for each of these modules there are parent proxy reported versions, but for the young child and teen versions there are self-reported versions as well. And as Alison's already mentioned, the PedsQL generic core scales delineate health across 4 subscales: physical functioning, emotional functioning, social functioning, and school functioning. The physical functioning item covers 8 items. The other subscales each cover 5 items, apart from school functioning, where the toddlers are only 3 items. So the school functioning item, a subscale within the toddlers module, doesn't include the school absence items. So we set about to develop this reduced item set, to reduce it from 23 items down to a more manageable number of items that will make it more tractable to valuation. And to do that, we use the LSAT data, as we mentioned, the LSAT data and statistical argument in the first session. So there are 2 different cohorts with the LSAC. We were recruiting in 2004 a group of infants who've been followed up through childhood and adolescence from 2004 up to 2018, and a group of 45-year-olds who recruited in 2004 and have been followed up until they were 19 years of age. So 2 longitudinal studies, the B cohort and the K cohort. There's also a separate cross-sectional sample of 11 to 12-year-olds who were recruited between 2014 and 2016, and they're the third sample that we focused on. So we've ended up with 3 analytical samples within our analyses: the cross-sectional checkpoint sample of 11 to 12-year-olds, what we've called the topper sample, which combines the 4-year-olds from the B cohort and the checkpoint and the K cohort, and then a separate third analytical sample, the Mallinson sample. Within the Mallinson sample, we looked at all the other children who were followed up longitudinally over at least 3 different time points, and we took 1 random observation for each of those children and combined all the children across the B and K cohort. So we ended up with 3 analytical samples: the checkpoint sample, the Mallinson sample, and the Doppler sample. So in order to develop this reduced item set for PedsQL generic core scales, we followed established methods in the literature. We particularly followed methodological recommendations of health economists based at the University of Sheffield in the UK, and we followed these three steps to analyse the data. First, we assessed the dimensional structure of the PedsQL generic core scales to identify whether we should stick with essentially the 4 dimensions or subscales within PedsQL generic core scales. And to do that, we did a number of different analyses. First, we started with exploratory factor analyses. We then followed that with confirmatory factor analyses, and then we came together as a group to analyse all of this data to determine whether we should stick with the original dimensional structure or whether we should adopt an alternative dimensional structure before we move forward with psychometric analyses. Once we had completed the dimensional assessments, we went through a series of psychometric assessments of each item within each of the selected dimensions or subscales. And to do that, we created 3 subsamples, each of a sample size of 500 for each of the 3 analytical samples. And then we applied a range of tests of Rush criteria, including threshold ordering, differential item functioning, and item level goodness of fit. And also we assessed the items using classical criteria, including rates of missing data, internal consistency, and rates of fluency and effects. And after we had completed all of those analyses, we came together as a group to decide on which items we should select within each of the subscales or dimensions for the reduced item set. And as part of that process, we pre-specified the criteria that we would apply to within our group decision-making processes. We prioritised the results from checkpoint analytical sample because this was the only sample that relied on children's self-reports. All the other data came from parent policy reports. And then we had some other criteria, so we ruled out items if they felt one more Rush criteria in each subsample. We then subsequently considered the results from the classical psychometric tests for the non-eliminated items. And we also considered the conceptual meaning of the shortlisted items. So if you had 1 item per dimension, would that item represent the subscale well enough on its own to convey the meaning of the subscale of the dimension? So very briefly, these are the results of the dimensional assessments. We did this for the different analytical samples. These are the results from the checkpoint children's sample when they were 11 to 12 years. You can see that, sorry, it's quite a busy slide, there's a lot of data on this slide, but essentially, if you look at the exploratory factor analysis in the left-hand table, you can see that, broadly speaking, the 4 dimensions, the items loaded onto those 4 dimensions, there were 2 items, the 2 school absence items, which are the bottom 2 items, that loaded onto a different factor. And those are the ones that we struggled with. But when we looked at the results across all of the different analytical samples, and we looked at the true factor analyses and the confirmatory factor analysis, then we came together as a group. We didn't come up with enough evidence to suggest an alternative dimensional structure to the original four-dimensional structure that was created by the PedsQL developers. So we took forward the original four-dimensional structure to the subsequent psychometric assessments. So once we had done that, we then did these psychometric assessments of the items within each of the within each of the subscales. These Rush criteria, these classical psychometric tests. These are results from the checkpoint sample of children when they were 11 years of age. So these are just the results of the items within the physical function in the subscale. So you can see the 8 items in the first column, and you can see the results of the statistical test, the Rush criteria, and the classical psychometric criteria in the column headings. And we went through each of these items and assessed them against each of these different criteria. So in this particular sample, analytical sample, we found that only one item met our pre-specified criteria, which is getting A's and A's. So at the end of that process, we ended up with a short list of potential items that we could take forward to the reduced item set. So for each of the 4 subscales, physical functioning, emotional functioning, social functioning, school functioning, you can see the potential items that we could take forward presented in the second column. We then went through this decision-making process to select preferred item. And so the thinking behind our final decisions is presented in the third column. So we've ended up with 4 items that we've taken forward to the reduced item set. So for physical functioning, we've identified getting aches and pains. For emotional functioning, feeling sad, for school, for social functioning, other kids not being my friend. For school functioning, keeping up with schoolwork. So those are the 4 items that we've identified for the reduced item set for the PedsQL generic course scales. And those have been taken forward to some of the valuation work that Elizabeth is going to describe in a moment. So we've identified a reduced item set with 4 items, one from each of the original subscales of the PedsQL generic course scales. And the idea here is that after set creation and further psychometric validation, the reduced item set should enable derivation of health utility values from previous and future applications of the PedsQL generic course scales. And this hopefully will expand the health utility evidence base for cost utility analyses. A number of strengths and limitations of the work that we've done. In terms of strengths, we closely followed methodological recommendations on how you should go about developing a reduced item set from an extended health status classification system. We've applied a range of different statistical methods within our analyses. We've used multiple subsamples. The LSAC data contain data from healthy children and also data from children with a range of clinical conditions. So we feel that the item set is valid for diverse general and clinical populations. There are clearly limitations with this work. We focus exclusively on an Australian data set, so it's questionable as to whether our data are generalizable to other countries. The self-report data are restricted to 11 to 12-year-old children. All the other data in our analyses come from parents who are reporting on behalf of the children. That's clearly a limitation. And a key limitation of this work is that there were no self and proxy report data for the same children reported at a single time point. And so we can't compare across respondent types in our analyses. we've just completed this work. The paper's just been accepted for publication by Value in Health, so it should be published fairly soon. I should have mentioned at the beginning, that was led by Joseph Kwan, who's a research fellow who's working with us in Oxford, and involved input from a number of people within this, who are here in this room. So thank you very much for your contributions. But that's a brief overview of how we went about developing this reduced item set because of the response. I don't know if anyone has any questions or would you want to go straight into the next. Yeah. Yeah.
Hi Stavros, yes, that's really interesting work. It's great to see what you've done. I've got lots of questions, but I'll focus on one. And that is around the choice of pain to represent physical functioning. So I think it's a bit of a diversion to most preference-based measures in that pain and physical functioning are usually seen as separate domains, and pain doesn't always load with physical functioning. So I wondered if you had any thoughts about whether you actually thought about separating out physical functioning into multiple items and selecting one not based on the rash to have a physical functioning and an aches and pains item, or and what do you think is a limitation of using physical functioning, representing physical functioning using pain?
Yeah, I would just need to double check that. I think in terms of the work you really find that pain seemed to load into the physical functioning sort of dimensional subscale. So that would come out in our data as a distinct, as a separate sort of subscale dimension.
But are you worried about not picking up certain types of physical functioning by using pain as the item to represent physical functioning?
Yeah, I mean, we should add, I mean, Elizabeth can come on to this again. We are also doing a valuation study that's going to be based on the full item set as well. Yeah. So this was a separate valuation study that's going to be based on, we were particularly concerned with discrete risk experiments that say it's going to be quite difficult. So discrete risk experiments. But we'll come to that in the next session.
So 4 items seems quite a low number, and I just wonder if there's any evidence in literature of what is an ideal or a acceptable number of items for participants to fill out. Is there any?
Yeah, I know this is say the time trade up and sat down. There's evidence to suggest that we should go above, say, 7 to 8 items in an evaluation exercise. So when we were deciding, we were thinking in terms of that sort of range